Hi everybody. So in today's video, we are going to be starting lesson 1 of unit 2. And the topic of today's video is going to be average rates of change and secant lines. The learning targets for today are the following. Number 1, I can determine the average rate of change of a function over a given interval. Number 2, I can write the equation of a secant line. So after we find the average rate of change, we're going to be writing equations of a secant line. And number 3, I can apply the average rate of change to calculate average velocity. So we're going to be looking at one application of average rate of change that comes up in real world problems, especially in the world of physics. So we're going to start with a little bit of a review today. We're going to start by reviewing what you know about slope. In previous math classes, we have learned how to find the slope of a line between 2 points. The slope of a line helps us describe the steepness of the line. So in other words, how slanted is the line? There are several different representations for slope, and another name for slope, and the one that we're going to use most often in this class, is the name average rate of change. So when I say average rate of change, that's just another name for the regular old slope that you've been doing since you were, probably in middle school. Here are some of the representations that you should be familiar with for slope. We often use the letter M to stand for slope, and I like to think that that's because it describes the movement between 2 points on a line. Another way we sometimes think about slope is as the rise over run. And we often use that thinking when we're looking at a graph and we want to find slope. We look at 2 points and we just count the boxes and we go rise over run. Another way to represent slope is that sometimes it's called the change in y divided by the change in x. And in this case, that delta symbol means change. So it's the change in the y values divided by the change in the x values. And that idea actually leads us to our first slope formula that we often learn, which is the formula y2 minus y1 over x2 minus x1. And the reason that those are connected is because to calculate the change in a quantity, we do subtraction. So change in y really is y2 minus y1, and change in x really is x2 minus x1. Now, when you get a little bit further, you often use function notation to represent the same idea. So you often will see f of b minus f of a all over b minus a. And this is essentially the exact same formula that we have here, except for instead of calling it y2, we're calling it f of b, meaning the y value when you plug in the number b. And then instead of calling it y1, we're calling it f of a, meaning the y value when you plug in the number a. Instead of calling it x2, we're calling it b, meaning the second x value. And instead of calling it x1, we're calling it a, meaning the second a value. And this is usually what the kind of formula we use when we're given an interval of values, which often we write with interval notation like this. Now, what I'd like to do next is review actually using these things to find slopes. So it says here, we can apply the idea of average rate of change to functions that are not linear, which means the graphs are not a straight line. To do this, we imagine drawing a straight line through 2 points and finding the slope of that line. So we know that slopes only really apply to straight lines. If your graph is not a straight line, we just draw one in and then find the slope of the one that we drew. For example, if I was given this graph and I was told to find the average rate of change of the function over the interval from -1 to 2. The important thing to remember here is that in interval notation, each of these values are x values. So on the graph, the first thing I would do is locate those values. So I would start by finding the first x, which is -1, and if I find that on the graph, the point that that corresponds to is right here. Then I would find the second x value, which is the point right here where x is 2. So I would be looking at this point on the graph up here. Now, what I'm going to do next is imagine connecting the dots here with a straight line. So if you imagine, and I'm just going to take the edge of my stack of Post-its here, if you imagine connecting the dots here with a straight line, this line is not really part of the graph, but it's the line that we're going to imagine because finding the average rate of change means finding the slope of that line. So to find the slope of this line, I like to use the idea of rise over run, which means I would count by rising 3 and then running 3, which means the slope is +1. So the average rate of change between those 2 points would be +1. Now, what if instead of being given a graph, we were given a table of values? So the second example here says, find the average rate of change. So in my mind, I know that that means slope of the function shown over the interval between -1 and 2. Again, we need to remember that in interval notation, both of these values are x values. So what I'm going to do next is find the appropriate pieces of information that I need from this table. If x is -1, I'm going to be looking at this point in the table where x is -1 and y is +1. If x is 2, I'm going to be looking at this point in the table where x is 2 and y is 4. When I have 2 points like this, I like to use the formula f of b minus f of a all over b minus a. And what we need to remember is that in this problem, our b would be our second x value, which from our interval we can see is a 2, minus f of, and then a would be our first x value, which in this table is a -1, all over 2 minus, and then -1. So when I do this computation, f of 2 means the y value when you plug in the number 2. So that would be the number 4. Minus f of -1 would be the y value when you plug in -1, which is +1. And then on the bottom, 2 minuses make a plus, so 2 plus 1 would be 3, which means this fraction simplifies to 3 over 3, which is 1. What you'll notice is that I got the same value for the average rate of change using both of these methods because this table is a collection of points that came off of this graph. It's just 2 different methods for getting the slope. Finally, we might look at this algebraically. So sometimes you're not going to be given a graph, you're not going to be given a table, you're going to be asked to find the average rate of change, but you're going to be given an equation and an interval. So in this case, the equation is f of x equals x squared, and the interval is -1, 2, which again are x values. When this happens, I always go back to our formula f of b minus f of a all over b minus a. But I need to remember that in this case, the a is -1, because that's our first x value, and the b is +2, because that's our second x value. So the next thing that I usually do is fill in those numbers. So I would have f of 2 minus f of -1 all over 2 minus -1. Now you'll notice that this formula that we've kind of ended up with here matches the same one we had here, which makes sense because these are all kind of connected. This is the equation that gives you this graph, which would give you this table. So you're going to keep kind of seeing these appear, and the reason I did that is because I wanted you to see 3 different ways of getting the same answer. So the next thing I would do to calculate f of 2, if I didn't have a graph and didn't have a table, is I would take the number 2 and plug it into the equation. In this case, 2 squared is 4, minus, and then if I plug in negative 1 squared is positive 1, all over 2 minus negative 1 becomes plus, so I get 3. Which means at the end here, I still get 3 over 3, which simplifies to 1. So I still get the same value for my slope, it's just 3 different approaches for figuring that out. Now on the next page, we're going to work on our next learning target, which is to write the equation of a secant line. In order to do this, we're going to need to review how to write the equation of a line. So in order to write the equation of a line, we always need to know 2 pieces of information: the slope of the line and 1 point on the line. Now, if you have more information, like let's say you have 2 points on the line, that's fine, but you always need to know the slope and 1 point at least. Then, in this class, we are always going to use what's called the point-slope equation, which I've written here for you. Y minus y1 equals m parentheses x minus x1. In this equation, the y1 represents the y value in the point that you know. The m represents the slope that you know. And the x1 represents the x value in the point that you know. So if we know a point and a slope, we're going to be able to fill in almost all the information in this equation. Now, when we write the equation of this line, we are going to be writing the equation of what's called a secant line. If you can think way back to geometry, we named any line that crosses through a circle in 2 points a secant line. So in geometry, we said that secant lines cross through a circle in 2 points. Now, in this class, we're going to name a secant line any line that crosses through 2 points of the graph of a function. So just like the line we drew on the previous page that we imagined when we found our slope, this line right here would be a secant line because it crosses through the function in 2 points on the graph. Graphically, if we wanted to, for example, write the equation of a line that is secant to the graph over the interval from 1 to 2. So we are writing the equation of a line that is secant to the graph over the interval from 1 to 2, which means these are both x values. Now, whenever you see in the instructions that you're writing the equation of a line, there's going to be a very specific way that I want you to organize your work. And the reason I want you to organize your work this way is because it's going to help you also organize your thinking so that you can kind of follow a process to find the right answer. So whenever the directions say write the equation of a line, in this case a secant line, you're going to organize your work like this. You're going to list out the ideas that you need, which is that you're going to need a point in order to answer this question, and you're going to need a slope in order to answer this question. After you have both the point and the slope, then at the very end, your last step is going to be to write the equation of the secant line. So I want you to get in the habit of listing those things down so that you know what you need to do in order to answer the question. And what you need to do is find a point, a slope, and then you can write the equation of your line. Now, to find a point, we have several different ways to do that here. We could use the first x value and find a point on the graph. If we look at the place where x is positive 1, on this graph, that would give us the point 1, negative 2. Or you could choose to use the second x value. In this case, if you use the second x value, which is positive 2, you're going to be looking at a starting point of 2, 0. Now, when you do this problem, it's kind of a one or the other. You can choose to use this point or you can choose to use this point. You do not need to list both. I'm listing both just to show you that you do have 2 options. Now, to find the slope, we need to imagine that secant line, which is going to be the line that would connect those 2 points on the graph. So in this case, because I have a graph, I would use the technique of rise over run in order to find the slope of the line that I'm being asked about. So if I do rise over run here, I would go up 2 over 1, which means the slope of my secant line would be 2. Then you finally, at the end, write the equation of the secant line. So in order to do this, you need to choose which starting point you want to use. I'm going to do it 2 different ways so that you can see that you could have 2 different answers, and they're both correct. The first option is to use the starting point 1 comma negative 2. So you would write y minus, and then since the y value that you're plugging in is negative 2, and minus a negative becomes a positive, you would turn that into a plus 2, equals your slope, which is 2, and then parentheses x minus the x value from the ordered pair, which is a 1. Now, if you had decided to use the other point as the starting point, you would write y minus, and in this case, the starting y value would be 0, equals, you would still use the same slope, which is 2, and then parentheses x minus your starting x value, which would be 2. Now, you don't need to do both. I'm showing you both so that you know that you have options, but you don't have to do both. You can choose one or the other depending on which starting point you decided to use. Now we're going to do the same exact thing, only we're going to do this numerically. So instead of giving you a graph, let's pretend we didn't have a graph and we just had a table. If I ask you to write the equation of a line that is secant to the graph over this interval, which means that these are both x values, then the first step here is going to be to organize your thinking by making a list that you need the point, you need a slope, and then at the very end, you can write the equation of your secant line. Now, just like before, we could use either one of these x values as the starting point. I'm not going to do it twice again. I'm just going to go ahead and use the 1 as the starting point. So in my starting point, if the x is 1, then I can look at my table and I can find that the y would be negative 2. To find the slope, I would use my f of b minus f of a all over b minus a formula. And in this case, the other point that I'm connected to has an x coordinate of 2, which is right here. So I would just do f of b, which in this case is the second y value, so 0, minus the first y value, which is negative 2, all over the second x value, which is 2, minus the first x value, which is 1. Now, minus minus becomes plus, so I have 2 over 1, which is 2. You'll notice I got the same slope, I just did it algebraically this time. So at the very end, we would write the equation of our secant line, which means we would have y minus the y coordinate. In this case, because you're plugging in a negative, that turns it into a positive, because 2 minuses make a plus, equals my slope, which is 2, parentheses x minus my x coordinate, which in this case is a positive 1. You'll notice we got the same secant line that we did here, it's just that this time we did it by using a table of values. Last but not least, we might want to write the equation of a secant line, but instead of being given a table or a graph, we're going to be given an actual equation and an interval, which means that these are both x values. So I would still organize my work that I have a point that I need. I'm going to organize my work that I need a slope. And then at the very end, I'm going to write the equation of the secant line. Now you'll notice I'm leaving myself some space because the slope is really where you're going to do some work and actually calculate something. So I like to leave myself some space there to have room to do my work. Now to find my point, I can use either starting x value. In this case, I'm going to use a starting x value of 1. To find the y value, I'm just going to plug the x into my equation. So if I plug in the number 1, I get 1 minus 1, which is 0, minus 2 times 1, which is negative 2. So you're plugging that number into the original function here, the f of x function. To find my slope, I would just do f of my second x value, which in this case is a 2, minus f of my first x value, which is a 1, all over 2 minus 1. Now, in order to find f of 2, I'm going to take the x equals 2, and I'm going to plug it in to my f of x function. So f of 2 would be 2 cubed, which is 8, minus 2 squared, which is 4. So that's 4, minus 4 again, which is 0, which means I get 0 minus, I already know f of 1 because I plugged in the number 1 to find my ordered pair here. So 0 minus negative 2, all over 2 minus 1, which is 1. 2 minuses make a plus, so I get 2 over 1, which is 2. Same slope I got before, just a different method of getting it. That means that my secant line would be y minus whatever my y coordinate is. In this case, that turns it into a plus 2, equals 2 parentheses x minus whatever my x coordinate is, which in this case is a 1. Now, the last target in these notes is going to be to look at one application of average rates of change. And the application we're going to look at today is the application of average velocity. Now, you'll notice that the word average is in both. So, average rate of change is the method we use to find average velocity. Now, average velocity can be calculated by finding the change in position over the change in time. And you can think about this as kind of like the change in y over the change in x. So the one thing I do want to note, which you may have learned in physics if you took that before, is that velocity is something we call a vector quantity. This means your answer for velocity could be positive or negative, and that the sign of your answer is actually telling you the direction you're traveling in. So if your velocity is positive, it means you're going forward or up, and if your velocity is negative, it means you're going backward or down. So in this problem, it says the position of a particle moving along the x-axis is given by a table of values below. Find the average velocity. So find the average velocity of the particle over the interval from 2 to 9. So since this is an interval, that means they're both input values, which in this case makes them time values. So what we're going to do is we're going to try to figure out the average velocity, which is going to be the change in position divided by the change in time. Now, the two kind of coordinates that we're looking at here are the position when the time is 2, which would be right here, and the position when the time is 9, which would be right here. So to figure this out, I would do the change in position, which means position number 2, in this case that would be 3, minus position number 1, in this case that would be 5, all over the change in time, which means 9, which is the ending time, minus 2, which is the beginning time. Now, if we actually do this calculation, we would get negative 2 over 7, and that makes sense because if our velocity is negative, it means we're going to the left. The units here are going to be change in position goes on the top, so the units would be feet on the top. And let's say that this time is actually seconds. Let's pretend that I had labeled that correctly. So we would say seconds on the bottom. So your answer here would be negative 2 over 7 feet per second. Now, another way we could ask this question is we could say the height of an object above the ground can be modeled by the function given. Find the average velocity over the first 2 seconds after it is launched. So if we want to find the average velocity, that means that we want to calculate the average velocity, which is the change in position over the change in time. Now it says here over the first 2 seconds after it is launched. So that means we're going from 0, which is the beginning, to 2. What that means is that we want to know the position at 2, that's kind of like our ending time, minus the position at 0, that's kind of like our beginning time, all over 2 minus 0. So since we need to figure out the position, we're going to plug these values into our function, which is the function that tells us the height of the object. So if I plug in the number 2, and I'm actually going to use a calculator for this one because the numbers get a little bit larger here, and I don't want to make an arithmetic mistake. So to plug in the number 2 on my calculator, I would simply do negative 16 times 2 squared plus 40 times 2 plus 5, which gives me 21, minus, if I plug in the number 0, I get 5 all over 2. And I got the 0 really quick there because I know that if x is 0, these terms kind of disappear, which means that in the end, I get 16 over 2, which is 8. Now my units here would be the change in position, and it says here that the height of the object can be found, it doesn't say the units, let's pretend they're feet. So feet per second. Let's pretend I had remembered to type the units. All right, that is it. Thank you guys so much for watching our first lesson of this unit, and I hope this made sense, and I will see you for some practice in class.